Hello, Accelerated Chemistry students. This is Ms. Crystal Foley, and this is your Chapter 9, Section 1 notes all over naming ions. So let's talk about monatomic ions. So ionic compounds consist of a positive metal ion and a negative nonmetal ion, and they're going to be combined in a proportion such that their charges add up to a net charge of 0. We know basically, what does that mean? That means that ionic compounds have an overall neutral charge. So for example, NaCl is going to be one sodium ion, which is Na+, and then one chloride ion, which is Cl-. That Na+ and Cl-, that +1 and -1 add up to an overall 0 charge. The most important step in learning the chemistry language is to be able to name and write the chemical formulas for all ionic compounds. So step 1, you got to learn about the ions that form ionic compounds. And so monatomic ions are what's going to be primarily used here. They consist of a single atom with a positive or negative charge that is going to result from either the loss or gain of one or more valence electrons. So let's look at cations. Remember, cations form when metallic elements lose their valence electrons. So group 1 elements have a +1 charge, and that means that they lose one valence electron. Group 2 ions have a +2 charge. That's because they lose 2 valence electrons. And group 3 ions have a 3+ charge, and that's because they lose 3 valence electrons. The names of the cations of group 1, 2, and 3 metals are the names of the metal, followed by the word ion or cation at the end. So for example, or if we're looking at Na+, that's the sodium ion. Ca2+ is the calcium ion, and Al3+ is the aluminum ion. Anions, remember, are nonmetals, and they tend to gain electrons to form anions, so their charge of a nonmetallic ion is negative because they gained extra electrons. So the charge of any ion of a group A, remember group A's are 1, 2, 13, 14, 15, 16, 17, and 18 on your periodic table. That is a nonmetal is determined by how many electrons they need to gain to be a noble gas. So let's look. So nonmetal charges. So all group 5A, so that would be group 15 on your periodic table, have 5 valence electrons, so they will gain 3 electrons to be a noble gas, so their charge will be 3-. Group 6A have 6 valence electrons. Remember, these are the elements in group 16. They will gain 2 electrons to be a noble gas, so their charge will be -2. And group 7A, which is group 17 on your periodic table, have 7 valence electrons and will gain 1 electron to be a noble gas, so its charge will be -1. And so anion names are going to start with the stem of the element name and then end in IDE. So for example, we have nitride, that comes from nitrogen. So we have the nitrogen ion, which is the nitride ion. Then we have the oxide ion, which comes from oxygen. And then we have the fluoride ion. We're going to practice these a lot in class, and then you'll get very comfortable with them, but they're also in the 60 element and ion names and symbols that you had to memorize over break. Then we have the metals that form more than one ion, and these are going to be in your group 3 through 12, or what we call groups 1, 1B, and 8B, and these are going to be the ones that are going to form your different charges. They're the transition metals. So the charges of the cations of many transition metal ions must be determined from the number of electrons lost. So iron can either lose 2 electrons and become Fe2+, or lose 3 electrons and can become Fe3+. So there are 2 methods that are used to name ions that can have more than one common ionic charge. So the first thing is to write the ion with the charge as a Roman numeral. And then the second one is using the Latin name and then changing the ending of the element name. So when you write the name of the cation with a Roman numeral, you write the name of the ion and then the charge as a Roman numeral in parentheses. So for example, this would be iron 2 ion, or the iron 3 ion, or the lead 2 ion, or the lead 4 ion. When using the Latin name, you write the root word and then different suffixes at the end to represent the charges. So if the name of the cation ends in OUS, it's going to be used for the lower charge. And if it's IC, it's going to be for the high-on charge. So that would be Fe2 plus, that's the lower of the two ions that iron can make. So that's ferrous. And then Fe3 plus, since it's the higher of the two charges, is ferric. Pb2 plus is plumbous. And Pb4 plus is plumbic. A few transition metals only have one ionic charge. Because of this, their ion names do not include Roman numerals. And your examples are silver, which is always +1, cadmium, which is always +2, and zinc, which is always +2 as well. So when you write their names, you don't need Roman numerals. So now let's talk about polyatomic ions. A polyatomic ion is composed of more than one atom. A polyatomic ion behaves as a unit and carries an overall charge. The sulfate anion consists of one sulfur atom and 4 oxygen atoms, and these 5 atoms together comprise a single anion with an overall charge of 2-, and it is written as SO4 2-. You can see the structure of the sulfate ion along with 3 other common polyatomic ions below, and all of these should be familiar to you because they were on your list that you needed to memorize. Ammonium, NH4+, nitrate, NO3-, sulfate, SO4 2-, and phosphate, PO4 3-. Now, the names and formulas of some polyatomic ions are shown to the right here, and note that most of the names end in either "ite" or "ate." Now, the reason they end in either "ite" or "ate, if we notice, is based on their number of oxygens. So sometimes the same 2 or 3 elements combined in different ratios to form different polyatomic ions. So note the number of oxygen atoms and the endings on each name. The ites always have 1 less oxygen than the ates do. And there's a pattern that we can see in the number of oxygens and the endings of the polyatomic ion names. The charge is the same on each of the polyatomic ion in a pair for which there is both an ite and an ate ion. The ite ending indicates 1 less oxygen than the one that ends in ate. However, the ending does not tell you the actual number of oxygens in the atom in the ion. For example, nitrate has only 2 oxygens and sulfite has 3 oxygens. So you need to memorize these, which is why you worked on them over break. So when writing a formula for a polyatomic ion that begins with H or hydrogen, you think of the H as representing the hydrogen ion H+, combined with another polyatomic ion. So for example, HCO3- is a combination of H+ and CO3 2-. So the charge of the new ion is going to be the sum of the H+ and the CO3 2-, and so it'll have an overall charge of -1, which it does. And as always, all of the information here on these Google Slides has been acquired and adapted from Pearson Chemistry's 2012 edition of the Textbook Resources CD and pearsonchem.com. Thank you so much. Have a good night.